Greetings. Now, this isn't the proof you were expecting. It is a proof, but in my limitless autism, it's a new proof, breaking a separate foundational formula and understanding of math. Sometimes I hate being smart, because I was supposed to be getting sleep to go to work tomorrow. Today, it's past midnight for me. I hate this. But also, gotta love having a big brain. So yeah, here's how zero point 0.9 repeating is not equal to 1. Also, as I said, I'm running on 0 sleep. And an energy drink. This is going to be incredibly rambly for the time being. I hope that I do not lose anybody. Okay, so, actually I'm just going to clear my inventory, because I'm going to be using my inventory to show stuff. Probably need colors. Alright, I'm probably not going to need all of these colors. I'm just here to show them for the purposes of the colors, and then I'm also going to actually need a black concrete to act as the decimal point. Alright. So, from left to right, let's assume these are 1 through 9. And then also I suppose I can use white concrete for 0, I suppose. I'm not really going to need many of these, because in all reality, it's mostly going to be the concept of 9 repeating, which I will just place out like that. Now, for current understanding, how you result in this is you make this equal to x. You then, and this is going to have me pull that real quick. You then multiply by 10, resulting in this. You then subtract that from this, resulting in only 9, because apparently we ignore the concept of having something out infinitely out this way. And then you divide by 9. So this is x. This is 10x. Subtracting the equivalent value of x from 10x is 9x, equaling 9. You then divide by 9 and get 1. Crap, I forgot that I have this set to toggle for Hypixel. One moment. Let me go ahead and fix that real quick. So, by that logic, this becomes that, and vice versa. However, there are 2 flaws in this logic. Before I go into that, though, let me address the supporting factors. First of all, there is the portion I addressed where, supposedly, there is no difference between the endpoints of either of these lines. Secondly, there is the concept that 1, and then I will do this to represent divided, by 3 is equal to, and then 0.3 repeating. Both of these assumptions, both that there is no difference in the endpoints of these, as well as this assumption here, are false. Let's look at the 1 divided by 3 is not equal to 0.3 repeating portion first. So, to begin, I shall compare the process of creating 0.3 repeating as well as the process of dividing 1 by 3. And for every step I take here, I will perform the process of long division for 1 step out this way. Obviously, we start with 1. Attempting divided by 3, that does not work. So we move one step over and divide 10 by 3. Now that is divisible by 3 with a 1 remainder. You may already see where I'm going with this. Let's go another step up here, and then go another step down here. And I'll actually place the 1 remainders directly below. Now, with this becomes a 10 for this, 3 with a 1 remainder. Once again, you may already see where I'm going with this. Now, let's assume I go out an infinite amount of steps here, and then I am going to continue this aligned up step and process like so. Now, across all of these steps, as I place them, there's the equivalent of a 1 remainder falling beneath them. Going out the infinite amount of steps to the, I mean, there isn't an endpoint, but the technical endpoint, I suppose you could say. Going out the equivalent amount of distance, the difference between 1 over 3 and 0.3, and then I will do this to mark repeating. The difference between these is a remainder, an infinitesimally small remainder of 1. Now, let's look at multiplying these by 3. With this, we take the end step, multiply this by 3, which becomes 9, and then add the 1, which becomes a 10, moving over here. We then repeat the process here. Multiply the 3 by 3, becoming a 9, add the 1, which sums that together like this. Now, let's look over here. With the simple process of 0.3 repeating, we get multiply 3 by 3, well that's 9, but nothing else to add to it to move it up. Multiply 3 by 3, well that's 9, this is 9, and all the way up, so that what we eventually get is 0.9 repeating. But, following the same steps here, will simply get you 1. Now, that already looks like fairly sufficient proof. However, as I said, I would mention that I would bring up the fact that it is assumed that the distances out this way, the infinite amount of 9s, are the same. Now, with the same visualization I made here, visualizing the endpoints, the hypothetical endpoints, because obviously there is no endpoint to infinity, let's repeat that over here. Now, with this is simply 0.9 repeating, so I will go out 4 blocks this way. Now, once again, let's assume we haven't done the multiplication by 10 yet. I'm going to go out by the same 4 digits. Now, let's look at what happens when we multiply this by 10. Every single decimal point here moves 1 space left. So that means this one becomes this one becomes this one becomes this one, and etc., and etc., and etc., all the way through until we have this. And would you look at that? There is a 0 here in the same space. Now let's clear that, because obviously what I'm trying to do here is prove that this isn't the case. Now, let's subtract this 0.9 repeating from 10 times 0.9 repeating. Now once again, this value is equivalent to x, and this is equivalent to 10x. Now, I'm going to go ahead and recreate it over on this side, just so that the act of subtracting it visually makes sense. Now, I would go to the other side, but that's that's a separate part of this. Because it's shock value that I'm leaving for the end. Go ahead and watch to the end, because shock value is at the end. Anyways, now this is simply 0.9 repeating, so I will go out like this and go ahead and clear this. Now again, what we are resulting from here is going to be 9x after subtracting 10x, or subtracting x from 10x and their equivalents. So, what do we get when we subtract 9 from 0? Well, that's not possible. But by normal mathematical rules, and I'm going to need the value for 8 back, we are going to pull 1 from here so that we can get a 10 for here. Now, we can subtract 9, resulting in 1. Now, what happens when we subtract 9 from 8? Well, once again, you can't do that. So we make this an 8, pull one of the ones, to make this an 18. Now we can subtract 9 from 18, resulting in 9. Now, this similar pattern proceeds all the way up the line. 8, pull 1, 18, subtract 9 is 9. And then repeating all the way up the line will eventually result in this being an 8, and then resulting in 0.9 repeating, trailing 1. Now that we've got that, this value here is equivalent to 9x. Now, let's go ahead and repeat the normal process that is used in this step and divide by 9. Now, I suppose everyone watching this video at least has a cursory understanding of arithmetic. I'm sorry for assuming that. If you don't understand arithmetic, this entire section is definitely going over your head. Anyways, can you put 9 into 8? My apologies. Like I said, I'm doing this in the middle of the night. Can you put 9 or 8 into 9? No. So you have to move on to the next step. Now, by rules of long division, this is now 89 into 9. And what do you know? You can do that. You know how you can do that? One moment. I need to put the decimal point down for reference. You can multiply 9 times 9 to get 81. You then subtract these values. 9 minus 1 is 8. And then 8 minus 8 is 0. You can then ignore this value and move on to the next step. And would you look at that, it's an 89 again. Repeat the same step. 9. 89 minus 81 is 8. 9. 81 minus 80. 89 minus 81 is 8. Repeat this step all the way down to the end, which will result in, wouldn't you know, 9's all the way down to this point. Now, at this point, we have divided and resulted in 8s and 8s and 8s all the way down. Now, this final step is a 9, resulting in a flat 0.9 repeating. And would you look at that, 9 times 9 is 81. So this leaves a perfect remainder of 0. So that's two different ways of showing that the concept of 0.9 repeating equals 1 is kind of illogical. Now, you want to know why I say there was a shock factor value to this? It's because if you take the same exact steps that are currently understood to make 0.9 repeating equal to 1, and just apply it to the other side of the decimal point, you get an infinite amount of 9s, which is functionally infinity. Not literally infinity, I know that there's a difference there. But you get what is essentially functionally infinity, equaling -1. After all, by that logic, you divide by 10, and you also, once again, ignore the fact that this exists. You then subtract the original from this one. Or is it? Okay. I remember how I applied the steps. Okay, so this is x, and this is 0.1x. So you would subtract this version from this one, resulting in negative 0.9. Then, since you have the equivalent of 0.9, or negative 0.9 equaling 0.9x, you would then divide by negative 0.9 to result in x equaling negative 1. Now, when viewed from this side, it makes a lot more sense for these two statements, these two numbers, to not be equivalent. Now, does me saying that factoring an infinitesimally small, or in this case, infinitesimally large factor, actually do anything? Okay, there we go. Now, let's go back to the step where this is subtracted from this. Now, in the prior state, where factoring in an infinitesimally large, in this case, factor resulted in a negative number and then resulted in negative 1, let's take this one more time. Now, for the sake of the subtraction, I'm also going to add a 0 here. Once again, this is going to result in a 1 by factor of taking 1 from this, making it an 8, and having this be 10 subtracted into 1. Then, this is going to result in a 9 by similar factor of pulling 1, adding a 10 to this step, and then subtracting. Now, once again, proceeding through the whole step, we get out to this point, wherein we've done to the point where this is blue, this is blue, everything is actually blue, and then we've got the 1 here from the current step. Actually, I'm pretty sure those got subtracted already, but it doesn't really matter for the explanation. That becomes 9, and then we've got this. And once again, I apologize, I am very tired. Or actually, this becomes just an 8. That's the wrong color. Like I said, I didn't really need all the colors, I just needed it for color coding for the numbers. Because unfortunately, I can't simply write the numbers. Alright, so I took x and subtracted 0.1x. So this value here is equivalent to 0.9x. Now, let's divide this by 0.9. Now, how do I do that? Well, I am going to multiply by 10. Nope, that's a 1. And then I'm going to divide by 9. Now, in this case, it's the same process. Go up here. 89 becomes 9 with a remainder of 8. 89 again, 9 remainder 8, 9 remainder 8, 9 remainder 8, etc., all the way down to this, which has this become remainder 8, and then 81 perfectly divides into 9. Now, once again in this case, we have an infinite amount of 9s only equaling itself. Now, here's the reason I ended up actually thinking about this in the first place. Not only did I find it to be almost incredibly heretical that two separate ways of writing a number could result in the same value, but also, by method of the proof of all infinities being the same, having every uniquely written number be its own uniquely written value, I kept getting into my head about the fact that under the values of 0.9 repeating being equal to 1, this number would violate bijectality. This simple one equation here would violate bijectality by having every 0.9 repeating and every correlated 9 repeating having two outputs for the same input both ways. So I just kept thinking about it and eventually realized, yeah, no, that's not how that works. Because math is fun, and I am incredibly autistic for discovering this. I'm not going to lie to myself. I'm so incredibly autistic for discovering this. Like, I could have just sat back, taken the same assumptions as every other mathematical genius in their time could have taken, and I could have just sat back and known the knowledge of our time. But I'm too autistic to let that slide. So I didn't let it slide. Which has resulted in both a proof that all infinities are the same, instead of there being a concept of countable and uncountable, as well as there being now a proof that one of the most widely understood pieces of math trivia is just wrong. I love it. I also hate it because I'm not sleeping tonight and I need to work tomorrow. This is going to be so fun. Great. Anyways, okay, bye.